guys, welcome to class. Today we're going to be looking at lesson 4.5 about rules of exponents, and we're going to learn two different rules today. We're going to talk about the product of powers property and the quotient of powers property. So before we jump in, we need to review a few things about exponents that are going to be really important for us to make sure we understand what we're doing today. So we talked about this before, but if we had something like 2 to the 4th power, that whole thing is what's called the power. The 2 is what we call the base, and the 4 is what we've called the exponent. Okay, and understanding this language is going to be really important to us because we're going to be talking about bases and exponents quite a bit. And when we talked about powers, we talked about how the exponent tells us how many times we are going to be multiplying the base. So if we were to take 2 to the 4th power, for example, and write it as a repeated multiplication, that would be 2 times 2 times 2 times 2. All right, so we're going to start with the product of powers property. So the word product there should clue in that we are talking about multiplication, because that's what product means. All right, and the product of powers property tells us that to multiply powers that have the same base, I want you to underline that, that's really important. All we have to do is add their exponents. Now, let's break down what that means here. Let's look at this problem that has the numbers there. If we had 4 to the 3rd power times 4 to the 2nd power, and we're going to go ahead and leave our answers with exponents because these will get to be really big. So we can do these without our calculator. We're not going to figure out what all of these powers are. But if you were to write 4 to the 3rd power using repeated multiplication, that would be 4 times 4 times 4. And then it's saying you would multiply that by 4 squared, which is 4 times 4. And so hopefully what you notice here is you are basically multiplying 4 5 times here. And so the other way I could write this is 4 to the 5th power. So essentially what I'm doing is adding those exponents to figure out what the new exponent should be. And 4 to the 5th power would be my answer. The key here is that we can only do this with things that have the same base. In other words, if this had been 4 to the 3rd power times, 3 squared, we couldn't do this rule because those don't have the same base. This only works if they have the same base. All right, so let's try a few of these now. Whenever you start the problem, the first thing that you want to ask is what is the base? All right, so in A, the base here again is 4. And the base never changes. Notice we did not in that previous example do 4 times 4 because the base stays the same. In other words, if you were to think about A, this would be like 4 times 4 times 4 times 4 times 4 times 4 times 4, that's 7 4s, and then times 11 more 4s. We don't want to write that out because that would be so many 4s, but notice the 4 doesn't change. The 4 stays the same, and so this could also be written as 4 to the 7 plus 11th power, and 7 plus 11 is 18, and so this is 4 to the 18th power. In other words, if you were to write all that out as repeated multiplication, you would be multiplying 18 4s. All right, and so this can be written as 4 to the 18th power. Now, there's not very much work to show on these, but I do want you to show that step of what you're adding here because you'll see as they get more complicated how important that is. All right, now let's look at example B. B is a little bit trickier. The first question we need to ask is, what is the base? And in example B, X is the base. 2 and 7 are not the base. In fact, we have a special name for that 2 and 7. In this problem here, 2 is called the coefficient, which is maybe a word you've heard before. 7 is also the coefficient. So 2 and 7 are coefficients. They are not the base. All right. So if I were to factor out the monomial 2x squared, in other words, break it into its pieces, hopefully you guys realize that would be 2 times x times x. In other words, the x is being squared, the 2 is not. The 2 is just that number out in front. And then 7x squared would be 7 times, and we'd have x times x times x times x times x times x, 6 x's there. All right, so as we break this down or factor this into its pieces, like we've been doing the past several weeks, what you should see is that the x is what's repeating. The x is the base. And so in this example, we see that we have 2 plus 6 x's, because there were 2 from the first monomial and 6 from the second monomial, and so that's 8 x's altogether. The 2 and the 7 we are allowed to actually multiply because they are not the base. They're like these numbers hanging out front. They're the coefficients. And so the correct answer here is this is 15x to the 8th power. All right, now again, this is a little bit tricky, and this is why in every problem you have to ask what the base is. In example A, 4 was the base, and so therefore the base stayed the same. The 4 did not change. But in example B, x is the base. 2 and 7 were not the base. They were the coefficients, and that's why we were allowed to multiply them, and the x is what stayed the same as the base. All right, so let's do some more practice with this. Looking at example 1, as always, the first thing that we want to ask is, what is the base? In this problem, 2 is the base. So this would be 2 to the 5 plus 12. In other words, if we were writing this out as repeated multiplication, it would be 2 times 2 times 2 times 2 times 2 times 2 12 more times, so lots of 2's. So this is 2 to the 5 plus 12, so my answer is 2 to the 17th power. And again, you can write your answer using exponents, so we're not going to use our calculator. You don't need to calculate what 2 to the 17th power is. You can leave your answer with exponents, but you want it to just be as simplified as it can be. All right, so in number 2, here we have three powers, that we are multiplying, but that doesn't really make it any harder. We still start by asking what's the base, and in this problem, 5 would be the base. And again, the base is whatever's getting repeated. So like this would be 5 times 5 times 5 times 5 times 5 times 5. Tons of 5's there. And so this would be 5 to the 6 plus 2 plus 3. So if there happen to be more than 2 powers, you just add all of the exponents together as long as they all have the same base. And so this would be 5 to the 11th power. All right, in number 3, we start by asking what is the base, and in this example, the base is x, and this would be x times x times x times x times x times x times a lot more x's. But the question here that makes this one a little bit trickier is we've got to think, is there an exponent with that last term there? And think about if you were writing this out as repeated multiplication, that hopefully you would see that you would have one more x there. This is actually x to the first power. Everything is raised to the first power, it's just that we don't always show that. But in this case, that's going to be important because you're going to add 6 plus 13 plus 1. And again, think if you were to write this out as repeated multiplication, you would have 6 x's and then 13 x's and then one more x. So you need to add that 1. And so this would be x to the 20th power as your final answer. All right, now as we go down to number 4, we ask what the base is, and in this problem, n is the base. N is what is getting repeated. If we were to break down or factor that first monomial, it would be 2 times n times n times n. 2 and 6 are the coefficients. There are those numbers out in front. So I am allowed to multiply the 2 and the 6, and then it is n to the 3 plus 6th power because I add the exponent. So this final answer would be 12n to the 9th power. Again, in this case, we're allowed to multiply 2 and 6 because they are not the base, which is why it is important to keep asking over and over again, what is the base? So right now I'd like you to pause the video, try 5 and 6, and then when you're ready to see if you got them right, press play again. All right, go ahead and check your answer with mine. In number 5, x was the base, so that's why I was allowed to multiply the 3 and the 5 because they were coefficients. And then remember, when there's not an exponent there, it's just 1. So this was 1 plus 6. So 15x to the 6th power is the final answer to 5. And then same thing on 6. Y is the base. So I can multiply the 4 and the 6, which is 24. And then it's y to the 5 plus 2. All right, so again, we keep asking, what is the base? In 1, 2, and 3, or really if you look at 1 and 2, 2 and 5 were the base, and that's why we didn't multiply them. In 4, 5, and 6, the variable was the base, and that number was the coefficient. All right, now we're going to look at the second rule, which is the quotient of powers property. And again, hopefully that word quotient clues you in that we are now talking about division. And we're going to look at these as fractions, because remember the fraction bar means division. Okay, now we are still looking at things with the same base. So that is still really important to us here. And we're going to continue to start each problem by asking what the base is. But let's look at this first example here and start by trying to write out the repeated multiplication. If you have 5 to the 7th power over 5 to the 4th power, that would be on the top 7 5s, if you were to write it out as repeated multiplication. And on the bottom, you would have 4 5s. All right, now, we know that 5 divided by 5 is 1. So essentially any 5 that's on the top and the bottom we can cancel out. And hopefully you see that what you have is 3 5s left on the top, and so that would be 5 to the 3rd power. Now, we don't want to have to write out the repeated multiplication every time, because that would really take way more time than we want as the numbers get bigger and bigger. So essentially, hopefully you see here that all you are doing is, in this case, subtracting the exponents to figure out what exponent is left, or how many of that base is left. All right, but just like before, the question that we have to start by asking is, what is the base? So as you move to the next example, A, we look at this problem and we ask, what is the base? Hopefully you see that in this problem, the base is 6. That if I were to write this out as repeated multiplication, this would be 6 times 6 times 6 times lots of 6's on the top, and then divided by 6 times 6 times 6 on the bottom. And so I can do 6 to the 8 minus 3, which means my answer to this problem is 6 to the 5th power. So when you're multiplying things with the same base, you add the exponents. When you are dividing things with the same base, you subtract the exponents. Now, B is again where it gets a little bit trickier, because now notice when we ask what is the base, hopefully you see that X is the base. 3 and 12 are again those coefficients. So the X is what's going to stay the same, and I'm going to do 7 minus 3 there. And so this would be X to the 4th power. But then I do also want to simplify this fraction as much as I possibly can. And so I need to ask what goes into 3 and 12. And hopefully you see that 3 goes into both of those. So I'm going to divide the top and bottom by 3. And I get 1x to the 4th power over 4. Or you don't have to have that 1 there. You could just say x to the 4th power over 4. Because again, because 3 and 12 are the coefficients, we can divide and simplify those. Now, really guys, this problem should look familiar to you, because we have simplified things like this before. We talked about how we could find the GCF, get rid of the GCF, and then whatever we're left with is the simplified fraction. In other words, for this problem, you could have written 3 times, I'm going to have 7 x's here. On the bottom, I'm going to break 12 into 2 times 2 times 3, and then 3 more x's. And then I can look and see what they have in common, which is a 3, an x, an x, and an x. And then whatever I'm left with is the simplified fraction, which you see that x to the 4th power, and then on the bottom, the 2. So this is exactly what we've just been doing, except now as the exponents are going to get bigger, we don't want to have to write out the repeated multiplication every time. And so I'm now showing you this little trick where all you have to do is subtract the exponents to figure out how many of your base you have left. All right, so let's try a few of these. So number 7, again, the first question we always want to ask is what is the base? And number 7, 5 is the base. This would be a whole bunch of repeated 5s. So this is going to be 5 to the 9 minus 2, and that's the work that you need to show. You should show that work on all of them. So the final answer here would be 5 to the 7th power. On 8, we ask what is the base? And in this problem, 12 is the base. So this would be 12 to the 7 minus 4, which is 12 to the 3rd power. And again, just like before, it says you can write your answer using exponents. So that's great. We can stop right there. Now 9 is a little bit different because on 9, x is the base. 4 and 24 are the coefficients. They are not what's getting repeated. It is the x that is getting repeated. All right, so I'm going to start by dealing with the exponent. So this would be 13 minus 9 here, and I'm going to leave the 4 and the 24 alone for just a moment. So this is 4x to the 4th over 24. So then my next question needs to be like what goes into 4 and 24, and in this case, hopefully you see that 4 goes into both of those, and so you end up with x to the 4th power over 6, or you could have like 1x to the 4th power if you wanted there. And that is your simplified fraction. All right, now the last thing we're going to look at is putting these two rules together. So you'll notice in 10, 11, 12, based on the fact that the fraction bar is a grouping symbol, that means that you first need to deal with the numerator and then divide the two. So in other words, we're going to do first the product of powers property and then the quotient of powers property, okay? So for number 10, we start still by asking what is the base? And in this problem, a is the base. So on the top, I have 10a to the 4 plus 3. And so this would be 10a to the 7th power over a to the 2nd power. So 10 is really the only coefficient here, so it's just going to stay. There's nothing to multiply or divide it by because it is the only coefficient. But it is the coefficient. It's not the base. It's not what's getting repeated. So now I'm dividing those powers. So this would be 10a to the 7 minus 2. And so your final answer is 10a to the 5th power. All right, let's do another one. In number 11, we start by asking what is the base? And in this situation, b is the base. So on the top, I have 13b to the 4 plus 4, which is 13b to the 8th power over, instead of b, I'm going to write that now as b to the 1st power, because remember we can always raise something to the 1st power, we just don't always put that there. But it's going to be important now because this is 13b to the 8 minus 1, and so my final answer is 13b to the 7th power. All right, make sure you're showing your work just like I am. So what I'd like you to do right now is pause the video, try number 12, and then press play when you're ready to check it. All right, go ahead and check your answer with mine. 12 is definitely the most challenging problem we've done. So just like always, we start by asking what the base is. In this case, it's y. So as I deal with the top, it's just 12 to the y to 12 times y to the 2 plus 8. So that's 12y to the 10th power over 16y to the 5th. So now y is still the base. So that's why I subtracted the 10 minus 5 and got y to the 5th on top. The 12 and the 16 can be simplified even more. And remember, I need this to be as simple as it possibly can be. And so I see that 4 goes into both of those. And so I divide the top and bottom by 4. And so this would be 3y to the 5th power over 4. And that's your final answer. Again, this is the same as when we wrote everything out with prime factorization. This is now just a little bit of a quicker way to do that. All right, so that's all I got for you today. Hopefully you understand the rules of exponents a little bit better. Have a good day.